Chapter 4 is going to give you some more examples on vectors, which is one of the reasons I wanted to look at this textbook, because I like how they introduce them. And it will be included in what we call the standard template library. We will look at some member functions of vectors. We will look at something called an iterator. We will also look at some special algorithms. And the textbook looks at planning code with programs with pseudocode. We may or may not look at that because you guys are already kind of doing that. This is the portion in the textbook that talks about the beginning of vectors, and they mention a few things that I want to highlight. One is STL stands for Standard Template Library, and they have containers in them. Vectors are a type of container. They're like arrays, except they're more flexible and powerful than an array. Also, the standard template library has algorithms that we can use, and I'll show you some special algorithms, and they have also something called iterators that you can use to process containers. The nice thing about vectors is that it's a dynamic array, which means it can grow and shrink, and so that's one huge advantage, and we'll take a look at how we do that. And then again, that they can use the algorithms. The first program that we're going to look at is called it's actually not the Heroes program, but the first program we're going to look at is the Hangman program in this chapter. And that one does use a vector. Also, when you do use a vector, you have to pound include vector, and pound include algorithm is going to allow us to gain access and use some of those special algorithms that I just talked about. And then there's also the timing feature that we use here in order to generate random numbers. I'm going to run this program so that you can see how it runs. It's a Hangman program, and so I started executing it here, and so far it says here I've got the little dashes here represent that's my word. So if I guess a letter, let's say E, and I entered a lowercase e, this automatically converts it to an uppercase E, and then it says I have 7 guesses left. And so far that I didn't guess anything correctly. If I guess a D, and it says I got D correct, then it's going to start executing, and behind the scenes over here on the left, I had put a breakpoint into my program, so it has stopped executing. And I wanted to show that to you because a breakpoint is one way for you to look at and see what the values are inside your code. Now right now it's giving away the fact that my word I want to guess is difficult, but let's go ahead and take a look at some of that execution. When you see on the left hand side here, you see this triangle, you can open that up and it gives you every single index value in that array of difficult. It shows you all the variables in your program. And if you're in debug mode, you can also put down what's called a pin. So for example, if I want to hover over this and I want to pin down what the word is, and then that pin will stay even when I take out the breakpoint, that pin should stay. And so as I execute, then I will be able to see what the word is, so I can have a little bit of a heads up. In other words, I could cheat. So if I'm going through this program, let's go back and look at the execution of the code, because I want to look at a couple of the things that we had here. Like it changed it to an uppercase E. It's keeping track of how many guesses, and I had a correct guess. So if I hit continue back here, so we can see what it's going to do when I have a correct guess, then it actually fills in that spot. So there's a lot of stuff here going on behind the scenes. So this is a nice little program to look at to see what it's doing behind the scenes. I am going to take that breakpoint out because I don't want to stop the execution all the time. And so if we take a look, it automatically creates a vector of words, and pushback fills that vector. So pushback is the way that we add items to a vector, and it adds them in that order. Guess is in the first position, hangman is in the second position, difficult is in the third position. But then down here, when we set and assign the word, for example, the constant is going to be the word, that's the word to guess, it always picks the 0th index. Well, we'd always know then eventually if we played the game again and again and again that the word is always going to be guess. and that's not what we want. We want to change these up a little bit. So to change them up, they use a special algorithm called a shuffle. So this is one of those special algorithms out of the standard template library, and it will take a vector, words in this case, from the beginning to the end, and it shuffles them and switches up the order. So that's why we got the word difficult, even though it said the word was assigned words bracket 0. And you can see you have a counting variable here that's going to count the number of incorrect guesses. And then this is the dashes on the screen that you saw that indicated the word without being guessed. It's also using a string library function .size. And if we scroll down, I kind of like the beginning of this while loop because as while wrong is less than the maximum wrong, and so far does not equal the word, then we're going to keep guessing. And that's the loop that we had entered. Right here is where they change the lowercase to uppercase. That's a string feature, so you can do that. And then we have a special while loop here that is going to say I'm going to check for the used .find guess. So I'm going to enter my guess, and it's going to look to see if it was used, and it's going to look to see if it can find that guess in the used list. So it's keeping track of all of my guesses that I've used, and that's actually just in a string. So again, this is a string library function where it's trying to find the letter guessed in the word used. And then if we do find it, and or I haven't gone past the end of, this is string in position, I believe that catches the end of bounds there. I'd have to look that up, meaning that it doesn't go beyond the end of the bounds or a position. Then it tells me that I've already guessed it. And then it will say guess is assigned to upper guess. So basically this just keeps you guessing until you run across a letter that you haven't guessed. So if I go back to that screen, you can see it execute. I'm going to enter the letter D, and it says you've already guessed D. And so it's going to keep me in that loop until I guess something else. So I'll guess a T, and it adds that to the word then. So that's kind of a nice little feature. But these are all special functions, either like in the string library or that standard template library, the vector library that you can use. And if I continue down, then eventually it's going to check. After it does the guess, it's going to count how many guesses we guessed. And again, now it's going to use that word find, and it's going to look for the guess now in the word. So it's using this string function find a couple different ways. And then it will continue until it reaches the end of the string, which is what this : end position will do. I also have my pin here that you saw that I had pinned down before when I was using the debugger, and so that will stay there the entire time that I am working with this program until I exit. And then it will continue, and it will, if I don't guess the word, if I take up too many guesses, it will tell me that. If I go ahead and guess the word, it will tell me that I have been successful. And so I guessed the word, it was difficult, and then it exits. So that first program it's kind of nice because it power packs a whole bunch of features into one program. And so that's the Hangman program. We're going to go ahead and take a look at Hero, Inventory 2 and 3 next in this chapter, but those will be on different videos. I'm going to try to keep the video links to 10 minutes or less on these.